Hello everyone, this is N. Kavita working as Assistant Professor in Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. Today we are going to see a topic on light emitting diode, which is an acronym of a word LED. So this presentation will cover the following content: the symbol, construction, operation and characteristics of an LED. We will now look into the basic concepts of an LED. LED is nothing but it is a heavily doped PN junction diode, or I can call it as a special type of diode, and this LED will have the electrical characteristics which is exactly similar to that of the PN junction diode. When you look into this LED operation, this LED will allow the current to flow only in the forward direction and it will block the current in the reverse direction. So this process is exactly similar to that of a PN junction diode. When you look into the symbol of an LED, we will just look up the symbol. The symbol is exactly similar to the PN junction diode, but the only difference is that we have got an arrow mark which is away from this triangle, which indicates that there will be an emission of light source. So this has two terminals, namely anode and cathode, which is exactly similar to that of the PN junction diode. The cathode is always the short lead and the anode is always the long lead. So this provides the basic symbol of an LED. We'll now look into the construction of the LED. So when you look into the construction of LED, it is very similar that this will have the same P-type material and N-type material, and this have a region called an active region. So this active region is exactly similar to that of the depletion region in case of PN junction diode. So this LED will have a P-type which will enriched with the holes and N-type material which will be enriched with electrons. And we obviously know that there will be the recombination between the holes and electrons, and there will be a region in the middle which consists of an immobile charge carriers. So that region is called an active region. The only difference in construction with respect to PN junction diode is that it emits the light. So this LED will be made up of various semiconductor materials, namely gallium arsenide, gallium phosphide, or gallium arsenide and phosphide. We will now look into the working of an LED. When you look into the working of an LED, it should be noted that it is exactly similar to that of the forward bias condition of a PN junction diode. When you observe here, there is a P-type material which is connected to the positive terminal. We have got an N-type material which is connected to the negative terminal. We know that when P-type is connected to positive and N-type is connected to negative bias, it obviously means that this is considered to be in a forward bias condition. We have to recall the operation of a PN junction diode. In forward bias condition, what exactly happens is that the electrons and holes will start to recombine. When there is a recombination of a charge carriers, it should be observed that there is the movement of electrons. The movement of electrons, because of the recombination process from the Fermi level to the valence band, will automatically emit an light in terms of photon. It should be observed that in LED, the major thing to be considered is whenever there is the recombination of charge carriers, the electrons will be travel from the Fermi level to the valence band, and intermediate there is the process of recombination. Obviously, it emits a light source. So whenever it emits the energy, it is in form of photons. We know that light is always enriched with photons. Photons is a charged carrier which will be having a neutral charge. That is, it has both positive as well as the negative charge carriers. We will now look into the characteristics of an LED, which is very simple. When you look up, whenever there is an increase in voltage, obviously there is the increase in current, which is exactly similar to the VI characteristics of a PN junction diode. It should be noted that only after a particular threshold value, the current will start to increase. This is the reason because there will be a charge carriers breakdown which occurs in the depletion region. There is another curve which is called as the output characteristic curve, and this is plotted between your forward current and the radiant power. It is very evident from these two graphs that the characteristics of LED is considered a linear characteristics graph. We will now look into the colors of an LED. When you look into the colors of LED, based on the emissions of different colors of light like red, green and white, the LED is coated with different semiconductor material. Gallium phosphide is coated in order to emit a red light emission, Aluminium gallium phosphide is coated in order to make a green light emission. Gallium indium nitride is allowed to make the white light emission. So these are all the colors of an LED where we can able to observe the emission of light in different colors. We will now look into the advantage and disadvantage of using an LED. The major advantage of using an LED is it consumes less energy. It is very cheap and readily available, light in weight and size. And it should be noted that LED will be having a longer lifetime. The major disadvantages of LED are it requires more power when compared to the PN junction diode, and the luminous efficiency of LED is very low. So when you look into the applications of an LED, it is very evident that we could find LED in various practical applications. The major applications are in security alarm system as a burglar alarm system, in electronic calculators for showing the digital data, and it can be used in digital computers for displaying your computer data. So this LED will provide an absolute interest in case of electron devices. Hope this video helps you to understand the basic concepts of LED. Thank you for watching the video.